The arrivals of customers over fixed time intervals in a bank follow a Poisson's distribution with an average of 30 customers per hour. The probability that the time between successive customer arrivals in between 1 and 3 minutes is, okay, so let's say the probability P of X, since it follows the Poisson's distribution, we can write Poisson distribution this can be written as Px should be equal to e to the power of minus lambda to the power of x divided by x factorial. Now where for x belongs to whole number. Okay, so x belongs to whole number. That means from 0, 1, 2, 3 and so on. That means 0 plus all positive integers. And here Px is the probability of x arrival. X is the number of arrivals per unit time. So let's write here x the number of arrival per unit time, and lambda here is the average arrival rate. So let's write here average arrival rate. See, if lambda is the average arrival rate, that means therefore 1 upon lambda will be equal to what? This is mean time between arrivals. So let's write mean time between arrivals. Okay. Now in the problem we are given certain values. Let's write those values here. So it's given average customer per hour is, that is lambda is given as 30 customers per hour, or we can also write this as half per minute. Therefore from probability this we need to find the probability P of x that is greater than 1 and lesser than 3, right? This is the probability that we need to find. This means P1 plus P2 plus P3, right? And we also know P is given by e to the power of negative lambda to the power of x by x factorial. So let's write here, we have already written this, Px is equal to e to the power of negative lambda to the power of x upon x factorial. So if we calculate this probability, so we can write here P x greater than equal to 1 lesser than equal to 3 should be equal to e to the power of minus 0.5 into lambda value is 0.5 to the power of 1 here divided by x factorial, x is 1 here, plus e to the power of minus 0.5 into lambda to the power of x. So x here is 2, so lambda is 0.5 to the power of 2 by 2 factorial, plus let's write below e to the power of minus 0.5 to the power of 3 by 3 factorial. 3 factorial is 6, so let's write here 3 factorial, and after calculation you will get this value as 0.392. So let's go back to the problem and fill in the blank. So the probability that the time between successive customer arrival in between 1 and 3 minutes is 0.392, and to the correct to the 2 decimal place. So we need to find the answer correct to 2 decimal place. So we can write this as 0.39. Okay, and this is our final answer. Now to get more detailed information on Poisson's distribution, you can refer to the NPTEL course lecture number 32, Poisson's process on probability theory and applications by Professor Prabha Sharma of the Department of Mathematics at IIT Kanpur.